Hello students, we are going to start with a new chapter that is moving charges and magnetism. In the previous lectures, we have studied about the electric field intensity due to a point charge and due to various other sections. We saw how to calculate electric field intensity due to various sections using Coulomb's law and Gauss's law. Similarly, in this chapter, we'll be studying about the magnetic field and different rules or theorems or laws to calculate the magnetic field intensity. So in this topic, we will just study about the basics of electric field intensity, which we have already studied. We'll just recapitulate. And magnetic field intensity, what are the sources for magnetic field intensity and how do we calculate the direction of magnetic field intensity? So as we all know, the source for electric field is a point charge. A point charge is going to have electric field lines around it, isn't it? If it's a positive charge, then electric field lines will move away from that charge. And if it's a negative charge, then the electric field lines will terminate on that charge. Similarly, the source for magnetic field intensity, magnetic field lines, the source for magnetic field is a moving charge. A charge which is moving in a particular direction, charges which are moving in a particular direction will give rise to current. So a moving charge that is also equal to what? A current carrying wire. This is the source for magnetic field. And then we also have a magnet, which is also a source for magnetic field, which we will discuss later. And how to find the direction of electric field intensity. To find the direction of electric field intensity, we had to place a unit positive charge, isn't it? We place a unit positive charge at that point and find the direction in which the unit positive charge would move. That was the direction of electric field intensity. To find the direction of magnetic field, we have many rules. We can use even mathematics, cross product. So many rules are there, but I'm going to state two simple rules. The first rule is the right hand thumb rule. The first rule is what, people? Right hand thumb rule. So what does this right hand thumb rule state? It states that imagine you're holding a current carrying wire in your right hand. Imagine you are holding a current carrying wire in your right hand such that the thumb should point in the direction of current. You imagine you're holding a current carrying wire in your right hand such that the thumb should point in the direction of current. In the direction of current, then the fingers encircled will give you the direction of magnetic field lines. Then the fingers encircled will give you what? Will give you the direction of magnetic field lines. This is the right hand thumb rule. We can just have an understanding. I have just illustrated through one diagram. Imagine you're holding a current carrying wire in your right hand such that the thumb points in the direction of current. You can also hold the pen along with me. So this arrow, correct? This pointer is pointing in the direction of current. So imagine you're holding a current carrying wire in your right hand. In your right hand, you have to hold in such a way so that the thumb is pointing in the direction of current. It's very important. All the problems, wherever we calculate magnetic field, we have to mention the direction. Otherwise, the problem is incomplete. So please understand, you can also hold a pen along with me. You hold this current carrying wire in your right hand such that the thumb is in the direction of current. Then the fingers encircled will give you the direction of magnetic field lines, isn't it? Then the fingers encircled will give you what? Will give you the direction of magnetic field lines as illustrated in the diagram also. So what you need to understand is, I'll just draw one wire here. I'll just draw one wire. And let us say there are 2 points on this wire, one to the right and one to the left of this wire. So to the right, what is the direction of magnetic field? Magnetic field intensity is a vector quantity like electric field intensity. So if you see carefully, just see carefully, thumb is in the direction of current. To the right of this wire, which I have illustrated in the diagram, my fingers are going in here, then they become parallel and then they come out. Are you following something? I repeat once again. So here what is going to happen? To the right of the wire, correct? To the right of this wire where I have marked the point A, and one more point is to the left of the wire, which is B. To the right of this wire, point A, my fingers are going in and then they become parallel and then they come out. At point A, the fingers are going in, they become parallel behind the wire, and then at point D, my fingers are coming out. My fingers are pointing towards me. isn't it? So here what is happening? Here at point A, the fingers are going in, correct? And then they'll become parallel and then they will come out. I hope you have understood. They go in, they become parallel and then they come out. So at point A, to the right of this wire, the fingers are going in. Here at point A, fingers go in. So magnetic field is in the inward direction. It is in which direction? It is in inward direction. And inwards we represent with a cross. And to the left of this wire, correct? To the left of this wire, to the right, fingers are going in. They become parallel. And to the left, my fingers are coming out. You can also just check it out. So fingers are coming out. So at point B, so the fingers are coming out. Therefore, magnetic field is in the outward direction. Magnetic field is in which direction? It is in the outward direction. This is the right hand thumb rule. This is right hand thumb rule. I can show you one more illustration like this. Let us say we have a current carrying wire which is placed horizontally like this. So you need to tell me what is the direction of magnetic field at the top and the bottom. So you hold the current carrying wire in your right hand such that the thumb is in the direction of the current. Thumb should point in the direction of current. Then the fingers encircle. See, thumb is in the direction of current. Then the fingers encircled will give you the direction of magnetic field lines, isn't it? So at the top, my fingers are going in into the board and then they become parallel. And then at the bottom, the fingers are coming out. The fingers are coming out. Those four fingers are pointing towards me. So you can also just check. At the top, the fingers are going in. At the bottom, the fingers are coming out. So at the top, the fingers are going in. So magnetic field is inward. And at the bottom, the fingers are coming out. So magnetic field is outward. Outward is represented with a dot and inward is represented with a cross. So I hope you have understood the direction using right hand thumb rule. We have another rule that is right hand clasp rule. This is also easier. Any one can be used in the for your problems. No need to use both. Right hand clasp rule. This is something like a vice versa of right hand thumb rule. What did right hand thumb rule stated, people? See, if you see right hand thumb rule, it stated that. So imagine you're holding a current carrying wire in your right hand such that the thumb should be in the direction of current, isn't it? Fingers encircled was giving you what? Fingers were encircled were giving you the direction of magnetic field lines. So, but here in right hand clasp rule, curl the fingers of your right hand in such a way such that the fingers encircled should be in the direction of current. Then the thumb will give you the direction of magnetic field. Are you following something? So in right hand clasp rule, what does right hand clasp rule state? Curl the fingers of your right hand, such that the four fingers, correct, are in the direction of current. Curl the four fingers of your right hand in the direction of current. Such that the fingers encircled are in the direction of the current. Then the thumb will give you the direction of magnetic field. Thumb will give you the direction of what? Magnetic field. It was the vice versa in case of right hand clasp thumb rule. That was, imagine you're holding a current carrying wire. Thumb is in the direction of current. Fingers encircled is magnetic field. But here, fingers encircled should be in which direction? Fingers encircled should be in the direction of the current. Thumb is in the direction of magnetic field. Like I can give you an example. Let us say we have a loop, correct, which is carrying current. Let us say this current is in which direction? Clockwise direction. And I'll take one more case where the current is in anti-clockwise direction. So in this case, what is happening? You curl the fingers of your right hand such that, correct, such that this curling of the fingers should be in the direction of current. In the first case, the fingers are to be encircled in the clockwise direction. So you can also do it along with me. In the first case, you curl the fingers of your right hand in the direction of the current, and then the thumb is pointing into the board, into the plane of the board, isn't it? The thumb will give you the direction of magnetic field. So in the first case, the encircled fingers, correct, should be in the direction of the current. Clasp your fingers, curl your fingers in the direction of the current. The thumb is pointing the direction of magnetic field. So in the first case, when the current is in the clockwise direction, the thumb is in the inward direction. Therefore, magnetic field will be inward. Magnetic field is going to be in which direction? Magnetic field is inward. In the second case, you curl the fingers in the direction of current. So in the second case, the current is in anti-clockwise direction. So you also curl the fingers in anti-clockwise direction. So if you curl the fingers in anti-clockwise direction, the thumb is pointing outward. That is, it is pointing towards me. So thumb will be in the outward direction. Therefore, it is represented with a dot. Magnetic field is outward. Magnetic field is in which direction? Outwards. And then here magnetic field is in which direction? Inwards. Are you all following something? So this is how we can use right hand clasp rule or right hand thumb rule to find the direction of magnetic field. See, we can use even for straight wire, we can use right hand clasp rule. Now, if you ask how, I can just show you the diagram. If you want right hand clasp rule to be used everywhere, which students find it more easier. So what you can do is you can just draw a current carrying wire. Say you wanted to find the magnetic field to the right of this wire. What is the magnetic field at point A? It was in the inward direction. So if you wanted to use right hand clasp rule, so you just imagine one loop to the right of this wire, because point P is to the right of the wire. So I am imagining one loop. Though it's a straight wire, I'm just imagining one loop to the right of the wire. Now curl the fingers in the direction of the current. So current is in which direction, people? Clockwise. So thumb will be in which direction? Thumb will be in the inward direction. So at point P, magnetic field is inward. If you wanted to find the magnetic field to the left of this wire, so this is a current carrying wire. This is the point P to the left of this wire. And I'm going to imagine one loop. I'm going to draw one loop. I'm going to draw one loop to the left of this wire, isn't it? And I'll curl my fingers of right hand only in the direction of the current, which is in the anti-clockwise direction. Then the thumb is going to point in the outward direction, isn't it? It is pointing towards me. So therefore, the magnetic field at point P is going to be outward. So you can use only right hand clasp rule, or you can use only right hand thumb rule. Most of the students find sometimes right hand thumb rule easier, right hand clasp rule easier. Whichever is fine, you can go with it. And SI unit for magnetic field intensity. SI unit for magnetic field intensity is Tesla. What is the SI unit for magnetic field intensity, which is denoted by B? And remember, in magnetic field intensity is a vector quantity. It is nothing but Tesla. We have another unit. We have another unit that is called Gauss. Another unit is there called Gauss. And 1 Gauss is equal to 10 power minus 4 Tesla. 1 Gauss is equal to 10 power minus 4 Tesla. We also have cross product. Right hand thumb rule. Right hand thumb rule is done. Right hand clasp rule is done. Now cross product. Very, very important cross product. You all know about the dot product, A dot B. A dot B is what? It will give us a scalar quantity. It will give us what? It is going to give us a scalar quantity. And what is the magnitude of A dot B? AB cos theta, which we have learned work done is dot product of force and displacement. Cross product, now if I study cross product or vector product, this is a vector quantity. Cross product will give us what? It will give us a vector quantity. Now that vector quantity will have two things. One is the magnitude and one is the direction. So first we'll write the magnitude of A cross B. Magnitude of A cross B is nothing but, we can write it like this, modulus of A cross B. And that is nothing but A into B into sine theta. Theta is angle between A vector and B vector. Direction is what is very, very important. Now, what is the direction of A cross B? Direction of A cross B is, let us say A cross B, since it is giving us a vector quantity, let us say that is C vector. I told no, A cross B will give us what? It will give us a vector quantity. Let us call that vector as C. So the direction of A cross B is such that, correct, is such that it is perpendicular to the plane containing A and B, or it is perpendicular to both the vectors A and B. Direction of A cross B is such that it is perpendicular to the plane containing A vector and B vector. That is, C vector is perpendicular to A vector as well as C vector is perpendicular to B vector also. It is perpendicular to both A vector and B vector. How do you find the direction is? You will use a right hand clasp rule. Right hand clasp rule you will use. So what you will do is, let us say, as it is given in the diagram, let us say this is A vector and let us say this is B vector. Let us say these two are in the same plane. Let us say this is that plane. Both are in the plane of the book, correct? You have drawn, you are writing, isn't it? And you have a page which is placed on the table. So now you want to find A cross B direction. How do you find the direction of A cross B? First, what you will do is you will point the four fingers of your right hand in the direction of A, and then you will rotate it towards B. You will rotate towards B. Then the thumb will give you the direction of A cross B. It's very simple. What will you do, people? If you want to find A cross B direction, you will point the four fingers of your right hand in the direction of A, correct? Four fingers, and then you will curl, you will rotate towards B. You will rotate towards B. Then the thumb will give you the direction of what? Thumb will give you the direction of A cross B, isn't it? So since A cross B, they are in the horizontal plane, correct? I'll point my fingers in the direction of A. and then I'll curl towards B, correct? Thumb is in the downward direction. Thumb is in the downward direction, isn't it? Thumb is in the downward direction. That is nothing but C vector, which is nothing but A cross B. If I want to find B cross A, if I wanted to find B cross A, first you will point the fingers in the direction of B, correct? In the direction of B, and then you will rotate it towards A. You will curl towards A. Then thumb is in the upward direction. So B cross A is going to be in the upward direction. B cross A is going to be in which direction? B cross A is going to be in the upward direction. So in whichever direction you are pointing, that will be the first vector. If you're finding A cross B, then you will point the four fingers in the direction of A, and then you will curl or rotate towards B, correct? Thumb will give you A cross B. If you wanted to first B cross A, if you want to find B, you will point and then you will rotate towards A. Then B cross A is going to be in the upward direction. Point the fingers in the direction of A as it is mentioned even in the diagram, isn't it? As it is clearly mentioned in the diagram. If you're finding A cross B, you point the four fingers in the direction of A and then you rotate it towards B, then the thumb will give you the direction of A cross B. Are you all following something? I can show you one more example. Let us say A cross B, they are A and B, they are in this plane, correct? In the plane of the board, in the vertical plane. So what I will do, I'll point in the direction of A and then I'll curl towards B. Then the thumb will point in the inward direction. Thumb is in the which direction? Thumb is in the inward direction. If I want to find A cross B, I'll point the four fingers in the direction of A and then curl towards B. B is down, correct? As you can see in this diagram, which I have given, which I have drawn here, A is at the top and B is at the bottom. So A and then rotate it down, bring it down. A cross B is inside. A cross B is inward. If you wanted to find B cross A, first what will you do? You will point in the direction of B, which is down, and then you will curl towards A. A is at the top. So thumb is in the outward direction. That is B cross A. That is B cross A. So it's very, very important. Directions are very important. Kindly make sure that you are learning right hand thumb rule or right hand clasp rule. Both if you learn, it's better. Whichever is easy, you can adopt. And then cross product. What is cross product giving you? A cross B is going to give us a C vector, which is a vector quantity. And the direction of C vector is such that it is perpendicular to both A and B, isn't it? As you can see, this B cross A is perpendicular to A vector as well as it is perpendicular to B vector also, isn't it? And how do you find the direction? Using your right hand rule, point the fingers in the direction of A and then rotate towards B. A cross B will be in which direction? Inward, or B cross A is going to be outward, isn't it?